Section 2.2b. Find the polynomial function with the following zeros. So this now is where we want to work backwards. We want to take the solution or the zero that we know exists and work backwards until what factor is going to produce that solution. So in this case, our function that has a solution of 2 would be produced by the factor x minus 2, and our solution of negative 6 would be produced by the factor x plus 6. FOIL this out, we get x squared plus 4x minus 12. Notice it does say write a polynomial function, so make sure you write it as an equation. F of x equals whatever you get when you multiply out the given factors. Letter B, now we have 4 solutions. F of x equals, our 4 solutions are going to be x plus 2, x plus 1, x, and x minus 1. Now, whenever you have multiple factors like this, it's going to get very cumbersome to multiply all this out if you don't go about this a logical way. Remember, whenever we have conjugate pairs, it's easier to multiply those two together because we do not need to FOIL these out. So anytime you're doing problems like this, always look for conjugate pairs. That is going to make your multiplication much, much easier. So in this case, our x plus 1 and x minus 1 are conjugate pairs. I'm going to multiply those together first. As I do that, I'm going to pull this factor of x out front and save that for the end. I'll leave the x plus 2 where it is. And now when we multiply conjugate pairs, remember that's just the first thing squared minus the second thing squared. Continue multiplying. Leave this factor of x alone. FOIL these two together. When we FOIL this out, we get x cubed plus 2x squared plus x minus 2. Sorry, this is a minus x here. Minus x minus 2. Finally, distribute that x through to everything, and we end up with x. Made another mistake here. This should be x cubed, not x squared. So now when I distribute the x through, we get x to the 4th plus 2x cubed minus x squared minus 2x. There's our final polynomial. Again, notice that the degree of our polynomial is the same as the number of solutions, and that better be the case when you get done here. Otherwise, you know that you have done something wrong. Letter C. Now when we have irrational solutions, it becomes a little bit more difficult to get to the polynomial. F of x equals, still x minus each solution. So x minus 6 plus root 3 and x minus 6 minus root 3. Simplify this before we worry about multiplying. This becomes x minus 6 minus root 3, x minus 6 plus root 3. Now, when we go to multiply all of this, we take x, distribute it through to everything, take negative 6, distribute it through to everything, take negative root 3, distribute it through to everything. So we're going to have a lot of terms here, but a lot of stuff is going to end up canceling out, and it's going to end up being a nice polynomial. Take x, distribute it through, we get x squared minus 6x plus x root 3. Take negative 6, distribute it through, we get negative 6x plus 36 minus 6 root 3. Take negative root 3, distribute it through. We get negative x root 3 plus 6 root 3 minus 3. Add like terms. F of x equals x squared Negative 6x minus 6x gives us negative 12x. X root 3 minus x root 3 is gone. 36 minus 3 is 33. And negative 6 root 3 plus 6 root 3 is gone. We're left with that quadratic equation. Whenever you start with irrational solutions like this, when you go to multiply everything out, all of your radical stuff should drop out. If you think about every time you plug into the quadratic formula, you have nice values you're plugging into the quadratic formula, but sometimes your solutions come out to be irrational. That's all this is. It's a situation where our solutions are irrational, but we still get a nice quadratic function out when we simplify everything. Okay, the next ones are really a continuation of what we did in section 2.1, or I'm sorry, 2.2a. Find all the zeros, sketch a graph, put 0 in for y, take out the greatest common factor here. I can pull out a 3x squared. That leaves us with x minus 8. Set each of those factors equal to 0. 3x squared equals 0. X minus 8 equals 0. We get 0. And we get 8. Don't forget to check for double roots, which would cause touch points. Remember, touch points can only come from even-powered factors, and they only occur when that even-powered factor produces less solutions than it should. In this case, 3x squared, we would expect 2 solutions because it's degree 2. We only get 1, so we know that that is going to be a touch point on our graph. Left and right behavior, look at this first term. It's odd, it's positive, odd-powered polynomials that have have positive lead coefficients fall left and rise right. So now when we go to graph this, intercepts are at 0 and at 8. We know this graph has to fall to the left and rise to the right. I know it touches at 0, so when it comes up here, it touches, comes back down before it comes back up and crosses there. Again, I don't know how low this goes in between the 0 and the 8, but again, we're not interested in that at this point. Letter B. Again, plug 0 in for y. When we plug 0 in here for y, this is already in factored form for us. So go ahead and set each factor equal to 0. We get x plus 2 squared equals 0. 3x minus 5 squared equals 0. Take the square root of both sides. We get negative 2. Take the square root of both sides here. We get 5/3. So there's our 2 solutions. Both of these are going to be touch points because both of them were even-powered factors that produce less solutions than they should. So both of those being touch points, using now our leading coefficient test, and we need to think a little bit here now. If we were to multiply all this out, we're going to get a degree 2 4 polynomial. So it's an even-powered polynomial with a positive lead coefficient. Those polynomials always rise left and rise right. So plot these intercepts at negative 2 and at 1 2/3. We know it has to rise to the left, rise to the right. Both are touch points. So our graph is going to look something like that. Last one. Again, plug in 0 for y. This is not factorable, so once again, we need to go to the quadratic formula. Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Simplify underneath that radical. 16 minus 4 is 12. Root 12 is 2 root 3. Take a 2 out of everything, we end up with 2 plus or minus root 3. Plug that into your calculator. 2 plus root 3 is between 3 and 4. 2 minus root 3 is between 0 and 1. Let's check out our right and left behavior. This is a parabola opening up, even powered, positive lead coefficient. Those graphs rise left and rise right. And there's a sketch of that graph.